Very warm welcome. My name is Freiland. I'm the accountable manager of HeliService. HeliService, as you might know, we are a helicopter operator, but we are also a maintenance company. And today I'd like to give you some insights on what we're working internally. It's called Intelligent Maintenance System. I presume you're all from the maintenance space, otherwise you wouldn't be sitting here. So I will start off with some very basics and then dig into some further details of what we do at HeliService. So let me see how this goes to the next slide. All right. So just some very basics, but which you all of course are very familiar with. But just to recap where we come from. So helicopters are very maintenance intensive. We always, as a rule of thumb, we say 4 times more intensive than planes. And looking at a flight hour in our operation, it makes up around 1/3 of the cost. And number 3, which is probably the most, let's say, painful, but also it explains a lot of our industries where we are. Technicians, so that they are able to release an aircraft back to service, typically need 6 to 9 years of training until they are at that point when they can release an aircraft back to service. Also is a good indication of the challenges we face, meaning we cannot just produce new personnel. It takes a very long time. If you look at a surgeon about has the same number of years experience to get to the point where he can do an operation. Availability is key, of course, because we're dealing with a lot of money. So just that to set the scene where we're coming from. I will only stay on this chart for a very short time, but this is the introduction of where we're going, and the colleague from RUAG has spent quite some time on explaining the maintenance process, but very simple. We have an aircraft, we get into service, we know the flight hours, we know the age, we know the general conditions. Usually we also look at where the aircraft is operating. So is it in a salty environment? Is it in a HEMS operation? Does it have a lot of hoist cycles? Is it a VIP operation? So that gives us some indication already what we are looking at, especially when it comes to corrosion. Then we do an assessment, we plan the maintenance, we complete the maintenance and return the aircraft back to service. So I presume this is the same process for almost every MRO, a very simple static process. Think about this when we go to the next slides. At the first step, you really don't know what you're dealing with. When we look at customer aircraft, even our own aircraft, and we do an inspection at the customer, and you only see so much. You only realize what the job really takes the moment you start disassembling the aircraft. So before we go into our actual process, and I'm sure depending on where you work and what you're facing, usually, and that is the case with almost all maintenance, it takes longer and costs a lot more than we think. And funnily, we all get accustomed and used to that. We all accepted it, that maintenance usually takes longer and costs a lot more. When you give your aircraft to a third-party MRO, this is what you're going to get. You will hardly see that your timeline is kept and then your cost estimate is kept. It's just not happening. And funnily, we all accept that. And what are the reasons for that? Insufficient planning. Then we have a lot of findings, unexpected faults. I dig into some more detail how we actually think we can improve. Missing parts. Yes, we have that I think with all large OEMs. There's again, a very surprising inefficiency in this industry, that all the operators just accepted that there are not enough parts. Whether it's Leonardo, whether it's Airbus, whether it's Bell, it's just not a good situation. We have basic wrong assumptions of how long maintenance tasks take. Just ask, for instance, an OEM how long a maintenance task takes, and ask an actual MRO how long a maintenance task takes, and you see already huge deviations. And then you take the reality and you see even more deviations. So we even wrong there. We have inefficient process in itself, and we have a lot of documentation. So those are just some hypothesis assumptions why maintenance takes longer and why it costs more. And it is a static process. So if you think back about this slide, it's a very simple process. We look at the aircraft and then we just start working, and we face the surprises along the way. So we have a very simple vision. We want to do it better. That's our vision. But how do we want to do this? And there are a couple of words there. Is accumulated experience and intelligent learning system. That's the bottom line, what we want to do. And I'll show you how we envision of doing that. So this is not a static process, but it is a process which goes in circles. So what we do is basically the core, and all we do, fancy name, intelligence maintenance system, but in fact it is intelligent, because what we do, we look at what has been done in the past, and we do that very systematically. So every maintenance which we have completed, we look at what were the tasks, so that is the scope, and with the tasks we understand or can have an expectations what are, and we call them unexpected expected. For instance, if you have an aircraft operating in a salty environment, you can of course expect some corrosion. By now, with most helicopters, you can expect some corrosion. Depending on the flight hours, depending on the environment, you know how much corrosion you can expect. And with that, you can start planning. You need to have sheet metal work. You can plan for the hours, you can plan for the cost. And you can plan for the time. So that is a simple example. You can ask any experienced technician, he will tell you for what type of aircraft he's familiar, expert with, that there will be certain elements that will automatically check and that will automatically find components to replace, and that you will not find in your AMP because it's not there, but you know you need to do the work. So that's what we're planning to, that's what we're actually doing. So there's two things we do. We try to predict the scope, and we do that based upon accumulated experience. So to give you an example, we do round about 10 1-year or 4-year inspection on the 139 per year. So we know what the planned was, we know what the unplanned was, we know how long the maintenance tasks were planned to take, we know how they actually took. So the moment we see a consistent deviation in a maintenance task, let's say replacement of a main rotor or tail rotor. So you have so and so many hours. So we have in the AMP 120 hours, but according to our experience, it always takes 140 hours. So we have an algorithm behind it, not very sophisticated, very simple algorithm, which changes those numbers every time we see a deviation. So with every circle, we get better numbers on how long a task actually takes. We get better numbers on what the actual scope is, and we get better numbers on what are the expected, unexpected findings. So that's what we're doing here. And of course, with every maintenance, every part of accumulated experience, we get better at our system. Now, another part is, and I started out with that, is missing parts. So the moment you understand better what the scope is, you can, of course, plan for parts. It's a bit tricky because you're not ordering parts without having seen the aircraft and having seen the faulty part, but at least you can plan for it. Some parts which are where you already know there's a low availability, you can plan for that, and in the broader scope you can much better prepare for the maintenance of the aircraft. The other element of that is that we give, and I'm talking about procurement again, a good transparency to our customers where we stand in maintenance. And that is only the supply of parts. So we have, and I'm not showing a slide on that, but we have a information portal where you as a third-party customer can see for each part which is required for your aircraft, whether that part is available, whether that part has been ordered, if it has been ordered, whether it's on the way, or whether there is an expected delay on the part. That is another element of this tool we're using, but in essence, what we call the intelligence maintenance system is nothing but collecting experience, structuring them, learning from them, and then applying them for the next maintenance job. And that is again in scope. So what do we need to look at? It's in the expected, unexpected, so findings which we presume to have. And then of course it is in duration of the specific task. And speak to whichever MRO operator you know, work with, or you are an MRO operator yourself. How often do you actually review and correct the time it takes for a specific task which is written in your AMP? That very, very rarely happens. It's a lot of work, of course, but otherwise you will never be able to predict how long the maintenance takes and how long it costs. And that's where we put in a lot of effort. The entire thing is, of course, a software solution. It's not entirely automatic because, of course, the moment we correct a time in our planning tool, we want to be very certain that this correction is valid, because from our program we already make the proposal to the customer, i.e. the projection on how long something will take and how much will cost. So the implication of making a change in our MP, if you like, is significant. So we need to be extra sure that it is actually solid. So that is our IMS. We have started with that system some 3-4 years back. We are refining it as we go. It will only get better the more information we put into it. But we are already seeing the improvement, and we will continue refining the system going forward. So that is already concluding our vision. I started with a very simple problem, and I start with a very simple solution. I think, as everyone knows, working in maintenance, this is not simple at all. But in essence, it allows us to predict the scope. It allows us to predict the time. As an operator ourselves, one could argue cost is what cost is, but time is very often more costly than the parts itself. So we as an operator, we are very, very keen to understand how long an aircraft will be out of service when it's back into service. That is absolutely crucial for us to be a good operator. And then eventually for us also, but for our customers, we are able to provide a maintenance at a lower cost, simply because our planning is better, and that has many implications. It means that we can deploy resources more efficiently, that we can plan for parts more efficiently, that we are less dependent on AOG orders, and you as a customer, you get your aircraft back earlier. So that is it, a very short presentation, introduction on what we do. If you have any questions on that, very, very happy to enter a discussion. Thank you.